Okay, our last question. Uh, JE plays a game involving a six-sided die. The faces are labeled with these numbers. The score for the game is the number that lands face up when the die is rolled. Following the table is the probability distribution of X. So we've got a biased die, so we don't have a standard set of values. You've got two typical questions in these type of problems, and question A is very typical. Find the exact value of P. So we have defined the value of P. How can we do that? What's the concept we have to understand?
You just add up the others and then what's remaining.
Yeah. What do the others add up to?
One.
Yeah. It's the idea that the entire probability distribution is certain. One of them will happen. So it all adds up to one. So for A, notice that the denominators are all the same. So we've got 1, 4, 5, 6, 7, 14. We've got 14 over 18 plus P is equal to 1. So with this type of question, either list them all going add, or add them up correctly and show that you're adding up the table to equal to 1. Because if you get it wrong for some reason, the first point for these type of questions, usually, not in this case, it's too easy. The first point in these type of questions is usually showing that you understand that the sum of all the probabilities equals 1.
What do you do when there's two variables?
Put them both in. Typically, they might be the same variable, P and 2P. If they're not, you must have some other piece of information, like the expectation is known as well. And then you can create an equation system. So you would put them in to give you one equation. Let's say one is X and one is Y. I've seen a question like this one. So you make one equation based on this with an X and Y, and then you've got another piece of information that typically would be giving you the expectation. And then you can create a second linear equation with that. And then you have to put it into the equation system solver. I can dig one of those up if you want. We can have a go at it next time. I have seen that question. So what's our value for P? 4 over 18. Can we simplify that? 2 over 9. Jahi plays the game once. Calculate the expected score. So usually there's something involving expectation in this type of question. And if you remember how to calculate expectation, you want to sum up, if you actually have a formula on the formula sheet, let's pull that one up and have a look at it. Yeah, I think it's easier to remember how to do it than to read the formula on the formula sheet. But let's pull it up anyway. So here we go. The expected value. What you've got there is you're adding up the X value times the probability for that X value. So you're adding up the X value times the probability of that X value. So it's X1 times P1 plus X2 times P2 plus ... Xn times Pn. So you have a formula that looks like this, a little bit easier to sort of think of. So we need use the correct notation. The expectation of X is equal to minus 3 times 1 over 18 plus minus 1 times 4 over 18 plus 0 plus 1 times 1 over 18 plus 2 times 2 over 18 plus 5 times 7 over 18. You can simplify how you write that in because they're all over 18. So you can, if you want to type it into your calculator like that, you can, that's fine. It's 1 over 18. So we've got minus 3 times 1, minus 3. We've got minus 1 times 4, minus 4. We've got 0. We've got 1 times 1. We've got 2 times 2. We've got 5 times 7. 35. What do we get as our value? Can somebody do it? Somebody reliable do it for me?
1.83.
Okay. Have we got it as a fraction?
7/18.
Much nicer.
No, 11/6, sorry. 7/6.
Sounds better.
Yeah.
11/6. JD plays the game twice and adds the two scores together. Find the probability that he has scored -3. Ooh, a bit more problem solving this time. If we look at the scores, he's played it twice, so he's got 2 scores. How many different ways can we get -3?
1.
What would he have to get -3?
-3 and 0.
-3 and 0? Do any of the others add up to give -3? No. So we just need the probability that he scores -3 and 0. Could we also have the probability that he scores 0 and then -3? So is there 2 different ways to score -3 total? Yeah. There's 2 different ways to score it, isn't there? You can get -3 and then 0, or you can get 0 and then -3. Because when we're multiplying them together, we're going to be having a total of 18 squared different possible outcomes. And there isn't only one that is good, there's 2, isn't there? So out of 324 outcomes, we're looking for, sorry, no, it's a 6-sided dice, there's 36 outcomes. There's 36 possible things that he can get. We could show this in a couple of different ways. Let me show it. So we've got -3, 1, 1, 2, and 5. So -3, -1, 0, 1, 2, and 5. -3, -1, 0, 1, 2, and 5. So if we look at an outcomes diagram, it's going to look something like this. This is going to give us -9, this is going to give us -4, there we get -3, here we get -2, here we get -1, here we get 2.
Wouldn't the first one be -6?
-6, thanks. This one's going to give us -6. This is going to give us -4, -2, 0, -1, 0, 1, -4. This one is going to give us -3. This one is going to give us -1, 0, 1, 2, and 5.
So what if the one above -4 give you 4? Instead of -4, what about the just 4?
It's 2.
So we're going to get an outcomes table like this one with a possibility of 36 different outcomes, and only 2 of them are going to give us -3. So the answer is going to be 1 out of 18. If we use the outcome diagram, we can see there is a possibility of 2 out of 36, which is 1 out of 18. If you do it using the probabilities given in the probability distribution, we've got 1 out of 18 times 3 out of 18. So we have the probability that he his total score is equal to -3 is equal to, there's two ways to get it. It's 1 out of 18 to get the first one. It's 3 out of 18 to get the second one. What do we get for that? So this gives us 1 out of 54. Which calculation is correct? The second one. Why? What's wrong with the first one?
Because that's only one possible outcome.
No, we're calculating with two possible outcomes.
But you
Not quite.
I don't know, this only makes sense.
The first method with the table assumes that each probability is equal, but it's an unbiased dice. Remember that this die is biased, and this table isn't symmetrical. We don't have 1 out of 6, 1 out of 6 for each of the probabilities. So if it was symmetrical, we would get the same value in each one. But because it's not, we need to approach it like this. This method here, we're assuming that each outcome is equally likely to occur, but it's not. It's a biased die. At the start of the question, it says it's a biased die. So each of these probabilities is not 1 out of 6, 1 out of 6. This outcomes diagram does help us see that there is only two possible ways it can occur, which is why we have this 2 here. But it isn't a suitable method for us calculating that probability. We need to calculate the probability of each possible outcome and then add them together. Because they're the same, we can just multiply, and it gives us this. So this is our correct answer.